partial differential equation with constant coefficient এবং সেই টাইপের ডিফারেনশিয়াল ইকুয়েশনগুলোকে কিভাবে সলভ করব, পিডিই কে কিভাবে সলভ করব সেই বিষয়টা আলোচনা করব। পার্শিয়াল ডিফারেনশিয়াল ইকুয়েশন উইথ কনস্ট্যান্ট কোএফিসিয়েন্ট ফার্স্ট কেমন দেখতে হয় সেটা একটু আমরা দেখে নিই। সো আওয়ার ফার্স্ট রিকল ইজ হিয়ার, recall 1. So a partial differential equation that means PDE, which is linear with respect to dependent variable and its derivatives that can be written as A0 del ny del nz del xn plus A1 del nz del xn minus 1 del y plus dot up to an del nz del yn. So here you will see all are basically same order, and here order is basically n. Then plus b0 del n minus z del x n minus 1 plus bn minus 1 del n minus 1 z del y n minus 1 plus m0 del z del x plus m1 del z del y plus n0 z equals to f of xy. But the coefficients are, I said, the constant coefficients. So where the coefficient a0, a1, an, b0, b1, bn minus 1, m0, m1, and all the coefficients are constants. So this is basically our PDE, partial differential equation, and also it is linear PDE of constant coefficient. And this expression is basically the general expression. So that we can write a0 dxn plus a1 dxn minus 1 dy plus an dyn plus b0 dxn minus 1 plus bn minus 1 dyn minus 1 plus m0 dx plus m1 dy plus n0 z equals to f. And that we can write briefly f dx dy equals to fx. Where what is dx? Dx is basically del x, and dy is the operator del y. So sometimes we can write and the note in some book কিছু বইয়ে তোমরা দেখবে এটাকে লেখা f d d dash z equals to fxy, and here d is considered as del del x and d dash is basically del del y, partial with respect to y. So now we'll write one important theorem so that we can recognize it one. So here our next recall is recall 2. So if u is a complementary function, so the general solution, if we consider the general solution of 1, so the general solution of 1, if we consider is z, so that we can write zc plus zp. In some book it is written cz plus pz, where zc basically cz is the complementary function. Complementary function corresponding to homogeneous equation, corresponding to the homogeneous partial differential equation f dx dy z equals to 0, and pz, this is basically particular integral of the non-homogeneous part of the PD1. PD1 means here if xy is non-zero, then we can say it is a non-homogeneous PDE. So now we'll come to the important theorem here. So what is statement of the theorem? If u be the complementary function, and z1 is a particular integral, of the linear partial differential equation f dx dy z equals to f of xy, that we have written here. So then what we can write, u plus z1, this is a general solution of the partial differential equation of the PDE star. So here the proof is very simple. If we move to the proof of this theorem, since u is a solution, so first the given linear PDE with constant coefficient is f dx dy z equals to f of xy. So and the corresponding homogeneous equation, linear homogeneous PDE is f dx dy z equals to, so here fxy, small fxy equals to 0, so this is 2. Now since u is a complementary function, so u is a solution of 2, so we have f dx dy u equals to 0. So here dx means del x and dy operator del y. So and again since z1 is a solution, that is particular integral of 1, so we have f dx dy z1, this is equals to fx. So this is 3 and this is 4. Now what to start? Now f dx dy of u plus z1. So that we can write it as f dx dy u plus f dx dy of z1. So this is basically 0 plus, here you will see from 3 this value is 0 and this is basically fx plus fx. So this is by 3 and 4. So what we get here, f dx dy, এটা পেলাম যে u plus z1, this is equals to fx. So that means, that implies u plus z1 is a solution, and that solution is basically the general solution of 1, and this completes the proof. This completes the proof. So here proof is done. Now we can write another result. Another recall is if z1 z2 dot zn are solution of f dx dy z equals to 0, then any kind of linear combination, that means c1 z1 c2 z2 plus cn zn, where c1 c2 are constants, is also a solution of f dx dy z equals to 0, where all ci's are constants. এটা আমরা বলতে পারি। So that theorem is very easy, এটা তোমরা নিজেরাই প্রমাণ করতে পারবে। Now we will come to the homogeneous differential equation with constant coefficient. So next recall linear homogeneous partial differential equation with constant coefficient. So আমরা মেইনলি এখানে একটা স্পেশাল টাইপ নিয়ে আলোচনা করব, যেটা হলো যে we consider say a0, dn plus a1 dn minus 1 d dash plus dot 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 an d dash n z equals to fx. Here the restriction is, here you will see all the partial derivatives are of same order. All are order n. So in that case, the complementary function of 1, the question is what is the complementary function of 1? So the complementary function of 1, that we can write, complementary function basically ki hote pare. So we assume that z equals to phi y plus mx. Okay, the trial solution like this. So then what will be dz? That will be m I dash y plus mx, and d square z will be m square phi dash y plus mx phi double dash, and dnz will be m to the power n phi n y plus mx, and d dash z, that will be phi dash y plus mx, d double dash z, that will be phi double dash y plus mx, and d dash nz and z, so that will be phi n y plus mx. So if we substitute all this value in the left hand side, so what we get? We get a0 m to the power n, a1 m to the power n minus 1 dot 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 n phi to the power n y plus mx. That will be the, so that will be the left hand side of 1. So we get left hand side of 1, that is equals to this one. So then this is 0. So this is 0. That implies phi of y plus mx is a part of the complementary function of the complementary function if m is a root, of the equation a0 x to the power n or a0 t to the power n, a1 t to the power n minus 1 plus an equals to 0. So here suppose the n roots of 2 are, that is 2, so n roots of 2 R, say M1, M2 dot 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 M. Now, one important note, if all M1, M2 up to Mn all are distinct, then the solution, general solution is Z equals to phi 1 y plus M1x plus phi 2 y plus M2x plus phi n y plus Mn. So that will be our general solution. We have the complementary function. So we have the complementary function. Complementary function of 1 is so ZC. So that will be our complementary function. Now the question is, if you have asked that kind of question, this question is very very important. So find the তুমি যেমন কোশ্চেন করা হয় যে find the complementary function of del 2z del x2 minus del 2z del x del y minus 6 del 2z del y2 equals to x. So here the question is basically complementary function. So here the solution. So trick is you will replace del x, that will replace by m, and del y will replace by 1. Then you will get the auxiliary equation. So the given linear PDE is del 2z del x square minus del 2z del x del y minus 6 del 2z del y square equals to xy. So the complementary function, then the auxiliary equation. Auxiliary equation is, so that will be m square minus m into 1 minus 6 into 1 equals to 0. So that means here m, value of m is 3 and minus 2. Hence by this result the m1 m2 are different here. So therefore the complementary function is ZC equals to phi 1 y plus m1x, so y plus 3x plus phi 2 y minus 2x, where phi 1 and phi 2 are smooth function or differentiable function. Okay. So this is basically the complementary function. Now in that way you can solve many other problems. Say if you have asked find the complementary function of say del 2z del x square plus 3 del 2z del x del y plus 2 del 2z del y square equals to x plus y. So this is problem number 2. So here we are interested to find out the complementary function only. So here the given PDE, this is a linear PDE, and you will see all our order is basically 2. Here this part is of order 2. So del 2z del x2 plus 3 del 2z del x del y plus 2 del 2z del y square. So this is basically x plus y. Now that we can write d square plus 3d dash plus 2d dash square x plus y. So where d is basically del x and d dash is del y. So now the auxiliary equation is m square plus 3m into 1 plus 2 into 1 square. This is equals to 0. That means m square plus 3m plus 2 equals to 0. So here m is equals to minus 2 minus 1. So now we can write the solution. Thus the complementary function of 1 is ZC, C for complementary. So phi 1 y plus mx, so y minus 2x plus phi 2 y minus x, where phi 1 phi 2 are twice differentiable function, or you can say smooth function. So in that way you can solve the problem easily. But question is when the auxiliary equation has repeated root. So this is all about the case when all roots are distinct. Okay. Now I'll come to another important note. Note 2. So this is note 1. Note 2, if when the auxiliary equation has the auxiliary equation has a repeated roots. Okay. So maybe the first m1, m2 dot mr, first r roots are equal and next roots mr plus 1 not equals to r plus 2 not equals to mn, and this is also not equals to m. So in that case, so in general, if m be a repeated root of r times, then the corresponding complementary function, then the corresponding complementary function CF, that will be z of c. This is equals to x to the power r minus 1 phi 1 y plus mx plus x to the power r minus 2 phi 2 y plus mx plus x phi r minus 1 y plus mx plus phi r y plus mx. So this is all about the repeated roots, because m is a repeated roots of r times, and the remaining part will be phi r plus 1 y plus mr plus 1x plus dot 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 phi n y plus mx, where phi 1, phi 2 and phi n all are smooth functions. So now here the question is like, when the auxiliary equation has repeated roots, তোমাকে একটা question দেওয়া হলো যে okay, you will solve or find the complementary function of del cube z del x cube minus 3 del cube z del x square del y plus 3 del cube z del x del y square minus del cube z del y cube when this part equals to 0. And you can ask here, because it is a homogeneous equation, or you can write the question, solve dx whole cube minus 3 dx plus 3 dx dy square minus dy cube z equals to 0. In that way you can ask, you have asked the question. So how to solve this kind of problem? Here we need complementary function or general solution. So here a homogeneous PDE, so in that case the complementary function, note for homogeneous linear PDE with constant coefficient, complementary function and general solution, that will be same. So here the auxiliary equation will be that will be m cube minus 3m square 1 plus 3m 1 square minus 1 cube, that will be 0. Because here we replaced del x, that is del z del x, that is m, and del z del y. Okay. So that we can write m cube minus 3m square plus 3m minus 1 equals to 0. That means it will be m minus 1 whole cube equals to 0. That means that m is 1, 1, 1. So 1 is repeated root and it occurs 3 times. So now the question is complementary function or general solution E of, we write is 1 of 1 is, so ZC equals to, so repeated roots 3 times, so that will be x square phi 1 y plus mx y plus x plus x phi 2 y plus x plus phi 3 y plus. So that will be the general solution or complementary function. So in that way you can solve this kind of equation. Now we'll come to the non-homogeneous equation with constant coefficient. How you will find out the complementary function. So next recall the non-homogeneous equation with constant coefficient, PD partial differential equation. So here if d dash z, this is equals to fxy, okay, and here you will see the general solution. The complementary function is of the form, the complementary function of one is z equals to c1 summation e to the power hx plus f1 hy plus dot cn e to the power hx plus fn hy, or zc equals to summation c1 e to the power f1 k plus that x plus ky plus dot cn e to the power fn k x plus ky. Okay, so now we'll come to the problem. Then আমরা একটা প্রবলেম করলে আমরা বুঝে যাবে যে এক্স্যাক্টলি কি বলতে চাইছি। So question 4, find the complementary function. Find the complementary function of 2 del 2z del x square minus del 2z del x del y minus del 2z del y square plus 6 del z del x plus 3 del z del y equals to 0. Or we can write the general solution because it is a homogeneous equation. Okay. So here one important observation, up to this they are all the second order, but here the first order is also present. So what we will do, so hence the auxiliary and hence the equation solution, here the equation. So we will replace del z del x by h and del z del y by k, so that will be f hk equals to 0. That is 2h square minus hk minus k square plus 6h plus 3k equals to 0. And we will write in terms of case quadratic in k. So that will be h minus 3 and that will be minus 2h square minus 6h. So what will be the value of k? K will be minus h minus 3 plus minus root under h minus 3 whole square b square 4 ac 2h square plus 6h by 2 into 1. So that will be minus h minus 3 plus minus 3 h plus 1 by 2. And from that, if we take the plus sign, it will be h plus 3, and if we take the minus sign, it will be minus 2h. So therefore the value of k is here h plus 3 and minus 2h. So therefore complementary function is yz equals to summation c1 e to the power hx plus ky. So k first is h plus 3y, this is our f1h, and plus c2 e to the power hx plus ky, so f2h, this is minus 2h. So minus 2h y. And that we can write e to the power 3y summation c1 e to the power h into x plus y plus summation c2 e to the power x minus 2y h. And we can write it also e to the power 3y some function of x plus y plus another function of x minus 2. In that way, maybe you have asked the answer. Phi 1, phi 2 are differentiable. But if you যদি আমরা in position of h if we make it quadratic in k, in that case what will be the solution? If we make it quadratic in k, you will get the value of h will be minus k by 2 and k minus 3 and k minus 3. So in that case, the complementary function ZC will be C1 e to the power minus k by 2x plus ky plus C2 e to the power k minus 3x plus ky. Okay, so that means summation C1 e to the power if we take y minus x by 2 k plus c2 e to the power minus 3x summation c2 e to the power x plus y k, and that we can write say some function of y minus x by 2 plus e to the power minus 3x. So maybe another function of x plus y. So this will be the